Let's talk about lines in the plane. For today, we'll need to know what slope-intercept form is, as well as point-slope form. So I've put them both up here for you. Slope-intercept form is y equals mx plus b. Remember that m represents our slope, and then x and y are just our values for x and y here. And then for b, for slope-intercept form, this is used to identify where the y-intercept is. For point-slope form, we've got y minus y1 equals m times x minus x1. Again, m is going to represent our slope, and then y1, x1, well, these are coming from a point x1, y1 on our line. Slope. This is the ratio of the number of units a line rises or falls for each unit of horizontal change from left to right. Others define this as how steep the line is. Let's take a look. Let's say I've got this graph here. There's a line, and on this line, I've got 2 points. One point is point 1, the other is point 2. For simplicity's sake, we'll call this point 1, so this makes this x1, y1, and we'll call this point 2, so this is x2, y2. Well, with this, I've got a distance between the x values, and I've got a distance between the y values. If I look at the x values, x1 to x2, I can find this distance by simply subtracting x2 minus x1. And for the distance, or the height here, for the y's, I can do y2 minus y1 to get just this height. Well, the slope is the change in your y values over the change in your x values. So it says here, moving left to right along this line, there's a vertical change, y2 minus y1 units, and a horizontal change, x2 minus x1 units. So how do I find the slope then? Well, if I know the slope is my change in vertical, or y, and over the change in my horizontal, which is x, then I could say m equals y2 minus y1 over x2 minus x1. Note here that these do have to be separate points, so x1 and x2 cannot be the same, otherwise we would end up subtracting them and getting 0 in our denominator, which we want to avoid. Let's do an example. Example A, find the slope of a line passing through the points -2, 0 and 3, 1. First, let's identify a few things. So we've got, let's say that this is point 1 here, so we'll call this x1, y1. And we'll say that this is point 2, so this is x2, y2. Well, that makes x1 -2, x2 is 3, y1 is 0, and y2 is 1. So then, given my formula to find the slope, which is, again, the change in y over the change in x, y2 minus y1 is going to be 1 minus 0 over my change in x, so x2 minus x1, 3 minus -2, 3 minus -2. Careful here with your double negative, so m equals 1 over 5. Your slope is 1/5. Example B. Find the slope of a line passing through these 2 points now. So again, for simplicity's sake, we'll call this point 1, x1, y1. And this is point 2, x2, y2. That makes x1 -1, x2 is +2, and y1 and y2 are actually both 2. The slope is your change in y over the change in x, so y2 minus y1 would be 2 minus 2 over x2 minus x1, so 2 minus -1. Now note here, we only said that x1 and x2 cannot be the same. y1 and y2 can be the same. So we could actually subtract this completely out and have a 0 on top, and that would be fine. M equals 0 over 2 minus negative 1 would be 3, but then 0 divided by 3 would just be 0. So your slope is 0. So then how can I use the slope and say a point on the line to find more than just one piece of this equation? What if I want the entire equation for this line? Well, here I'm going to use point slope form. It says, when the slope of a line and a single point on that line are known, you can write the equation of the line in a form called point slope form. This is very similar to the last picture. The difference here is that instead of calling this x1, y1 and calling this x2, y2, I'm simply going to call this point x and y. But the same kind of concept is there. So to find the slope, you would subtract the change in y over the change in x. So that'd be a y minus y1, and then your x would be x minus x1. So your slope is m equals y minus y1 over x minus x1. But if I multiply then both sides by this x minus x1, then I get m times x minus x1 on one side equals y minus y1 on the other side. That's actually what point slope form is. Y minus y1 equals m times the quantity x minus x1. So that's where this is derived from, is actually using it from the definition of a slope. Let's use it in an example. Example A here. Find the equation of a line in slope-intercept form that passes through the point 1, negative 2. Let's pause there and label that. That is going to be my x1 and y1. And this has a slope of 3, so m equals 3. Okay, point slope form, y minus y1 equals m times the quantity x minus x1. Let's plug in these values. x1 is 1, y1 is negative 2, and my slope m is 3. So this would be y minus negative 2 is equal to m is 3 times the quantity x minus x1 is positive 1. Y plus 2 is equal to, distribute, 3x minus 3. And finally, let's subtract 2 from both sides here. So I've got y equals 3x minus 5. This is the equation for that line in slope-intercept form. So this is slope-intercept form. All right, lastly, let's talk about parallel and perpendicular lines. You may recall from earlier classes that parallel lines run side by side, right? So they're two distinct non-vertical lines that are parallel if and only if their slopes are exactly equal. So that's the key part, is the first slope, m1, has to be exactly the same as the second slope, m2. So how would I use this? Well, let's say that I have an equation and I want to find another equation, okay, for a separate line that is parallel to this one, but I only have one point for that other equation. So find the equation in slope-intercept form for a line that passes through the point 2, negative 1, and is parallel to the line 2x minus 3y equals 5. Well, first, let's get this other equation. Let's get this in slope-intercept form. So 2x minus 3y equals 5. Let's write that over here. And let's solve for y. So subtract 2x from both sides. We'll get negative 3y is equal to negative 2x plus 5. And then we'll divide both sides by negative 3. So this gives me y equals negative 2 over negative 3. We'll say that's positive 2/3 x. And then positive 5 over negative 3, minus 5/3. So this is my first equation. And more importantly, this tells me what my slope is. The slope is 2/3. So m1 equals 2/3. And since I want these two lines to be parallel, that means that their slopes must be exactly the same. This tells us that m2 must also be 2/3. And now that I've got this slope and a point for that other line, here this is x1, y1, I can use point slope form to find the equation for the second line. Y minus y1 is equal to m times x minus x1. Let's plug in what we know. y1 is negative 1, so y minus negative 1 is equal to the slope here, 2/3. Quantity x minus x1 is 2. Let's distribute here and clean this up a little bit. Y plus 1 is equal to 2/3 x and then minus 4/3. Remember, if you're multiplying a fraction to an integer, you're only multiplying to that top. And we've got to subtract this 1 from both sides. Since these are in thirds, what I'm going to do here is I'm going to subtract 3/3. Leaving us with y equals 2/3 x, and then negative 4 minus 3 minus 7/3. This is the parallel line. What about perpendicular then? Two distinct non-vertical lines are perpendicular if and only if their slopes are negative reciprocals of each other. I call this flip and switch. Let me write that down. Flip and switch. What that means is, whatever your first slope is, write it as a fraction if it's not already a fraction. Flip it upside down, so the numerator becomes the denominator becomes the numerator, and then switch the sign. If it was positive, it becomes negative. If it was negative, it becomes positive. Let me show you in this example. Example B. Find the equation in slope-intercept form for a line that passes through the point 2, negative 1, and this time is perpendicular to the line 2x minus 3y equals 5. Well, this is the same first line as what we had before, and that ended up being y equals 2/3 x minus 5/3. So I'm just going to remember that y equals 2/3 x minus 5/3, and let's write that here. Y equals 2/3 x minus 5/3. Double check that that's right. Exactly. Perfect. So that tells me that m1 is this slope 2 over 3, 2/3. In order for these lines to be perpendicular, their slopes must be negative reciprocals. Flip and switch. This is a fraction. Good. So I'm going to take this fraction, I'm going to write it upside down, flipping it 3/2, and then I'm going to switch the sign. So this sign is positive 2/3 x. I'm going to make this negative. So m2 is negative 3/2. Now use this and your point, x1, y1, in point slope form to find the equation for this perpendicular line. So this is y minus y1 is equal to m times the quantity x minus x1. Let's fill in everything we know. Y minus y1 is negative 1 is equal to, the slope for this perpendicular line is going to be negative 3/2 times the quantity x minus x1. So x minus 2. Okay, let's distribute this negative 3/2 and simplify this a bit. Y plus 1 is equal to negative 3/2 x. Negative 3/2 times negative 2. So this is going to multiply to just the top part of this fraction, making this 6/2. 3 times 2 here, and then negative times negative. Now this is actually 6 over 2. I can reduce this. This is simply 3, because 6 divided by 2 is 3. Finally, subtract 1 from both sides. And the equation for this perpendicular line is y equals negative 3/2 x plus 2.